I hope all of you are doing good. Let's start today's chapter, data handling. And after reading this chapter, you will be able to know about all these topics. Okay, so let's get started. Introduction. In our daily life, we come across information regarding marks obtained by students, height of students, age of students, etc. Each type of such numerical figure is called an observation, and collection of all observation is called the data. The word data means information. It should be remembered that data is a plural term. For single observation, term datum is used. In any statistical investigation, first step is the collection of data, but the observations collected by an observer cannot be put to any use immediately and directly. That is why it is called raw data. After collection of data, it has to be compiled and put in such a way that it can be interpreted, means understood. Data can be presented in the simplest form of pictograph, bar graph, table bar graph. Pictographs are already done by you in earlier classes. Here we will discuss bar graph. Okay, bar graph. A bar graph is a pictorial representation of the numerical data by a number of bars of uniform width with heights in proportion with data, either vertically or horizontally with equal spacing between them. The examples given below will help you to revise the concept of bar graphs and method of drawing them. Okay, so example 1 is given here. This table shows the number of books of different subject in a library. Okay, number of physics books 100, 125 chemistry books, 75 biology book, 75 history books, and 50 geography book. So here we have to draw a bar graph to represent the above data. Okay, see, take the subjects along the x-axis. You know, this is x-axis, right, and this is y-axis. Okay, so we'll take subject along the x-axis and the number of books along the y-axis. Construct the bars of same width with same distance between them. Let us take the scale as 25 books is equals to 1 centimeter. Okay, maths extension, bar height gives the frequency of each category. Bars should be of equal width with equal gap in between. Always remember that. It is easy to compare the result by bar graph. Okay, now interpreting a bar graph. Okay, in example 1, we do a bar graph. Now we will interpret a bar graph. Okay, so here is a bar graph given to you which is showing the approximate lifespans of some animals. Okay, so we have to read this graph and answer the questions, right? First, how many years does 1 unit length represent? So here you can see 1 unit represents how much? 1 unit length is equals to 4 years, right? Number 2, according to bar graph, what is the approximate lifespan of a rabbit? Okay, here if you check rabbit, A is a rabbit. So approximate how much? 8 years. Deer is what? B. Okay, approximate 15. Cat is a C. So approximate lifespan is 12 years. And a rat is E. Okay, so approximate 4 years. Okay. Third is, which animal has the longest lifespan, which animal has the shortest lifespan? Okay, longest lifespan, as you can see, D. D is what? Elephant. And shortest lifespan, rat. Okay. 4, what is the ratio of the lifespan of elephant and a rat? Okay, if we talk about elephant's lifespan, it is about how much? See, 32. Okay, 32 ratio, and we have to find out the rat. Okay, so rat 4. So let's find out the ratio. 4 ones are 4, 4 eights are. So 8 is to 1. This is the ratio. Okay, and which two lifespans are in the ratio of 5 is to 6? Okay, so 5 into 6 is, how can we find out ratio of 5 into 6? Let's take the ratio of deer's lifespan. What is the deer's lifespan? Deer's lifespan is 15. Okay, and bear's lifespan is 18 approximate. So 15 by 18 is 5. 3 5s are 15, 3 6 are 18. So the ratio is 5 is to 6, right? So the answer is deer and bear. Okay, deer and bear's lifespan is in the ratio of 5 is to 6. Okay. Next, double bar graph. A bar graph shows two sets of data simultaneously. It is useful for the comparison of that data. Example 3, double bar graph is given, which is showing the average rainfall of two cities. Means in one bar graph, we can show the average rainfall of two cities by using double bar graph. For last 3 years, read the bar graph carefully and answer the questions given below. Okay, what are the questions given here? What does each 1 centimeter block on the vertical axis represent? Okay, as you can see, 1 centimeter is equals to 50 millimeter of rainfall, right? 2. What was the average rainfall in city A in the years 2007, 2008 and 2009? Okay, 2007 is 375 millimeter. Then 2008, okay, we are talking about just a city A. In 2008 it is 425, and in 2009 it is how much? City A, this is 225 millimeter. Okay. In third question, in which year there was maximum rainfall in city B? Okay, this is the city B. Maximum rainfall, as you can see, is the answer is 2009. Okay. 4. What is the difference in the rainfall of the two cities in the year 2008? Okay, 2008, if we compare, okay, we have to find the difference. City A 425 and city B how much? 275. Okay, and let's find the difference. 150 millimeter. Okay. And fifth question is, in which year the difference between the rainfall of two cities is maximum, B minimum, and how much was this difference? First, you will find out the maximum. Maximum, you can see 2008, okay, and minimum is, you can see 2009, and you will find difference also, okay, difference. Let's do exercise 5.1. The following table shows the number of students in a school playing the 5 different games. Okay, represent this information on a bar graph. Okay, so on x-axis we will take games. Okay, games are tennis, T for tennis, H for hockey, C for cricket, F for football, and B for basketball. Okay, now number of students are given here. So we can choose any scale. Okay, so let's choose scale of maximum is 450, 100, 200, 300, 400 and 500. Okay, you can also take the gap of 50, right? So you have to represent now this information bar graph. Number students playing tennis. How many students playing tennis? 100. Hockey 225 means more than 200. Cricket 450. 450 is between 400 and 500. Football is played by 150 students, means 150 is between 100 and 200. Okay. Basketball is played by 125 students. Okay. So 125 students. Okay. Students. Organizing and grouping data. The information collected is always in an unorganized form, which is called a raw data. To draw any meaningful conclusion from this raw data, we need to organize the data. Let the marks obtained by 30 students of class 8 in a class test out of 50 marks according to their roll numbers are, okay, this is given. This data can be arranged in tabular form using tally marks. Okay, groups 0 to 10, 10 to 20. Okay, 0 to 10 means here your marks will come, means if a person is getting 1 mark, we'll put 1 bar here. If person is getting 5 marks, we'll put 1 bar here. Okay, 0 to 10 means less than 10. That is, okay, we will not write, if a student is getting marks 10, we will not put a bar here. We will put bar in this group only. Okay. So groups are given. Okay, then here tally marks and the frequency. So this way of presenting data is known as frequency distribution, right? And we can draw many inferences from this frequency distribution, such as A. Only 2 students scored marks between 0 and 10, as you can see here. Okay. B. 8 students scored marks between 10 to 20, and also 30 to 40. Okay. The groups 0 to 10, 10 to 20 are called class intervals. Okay. Remember that these groups are called class intervals. Example 4, given below are the ages of 35 students of class 8 in a school. Prepare a frequency distribution. Okay, this is called frequency. Here groups are not given, age is given. Okay, age 11, 12, 13, 14 up to 16. Then tally marks and the frequency. Total is 35. Okay, and always remember, always add a frequency. Okay, see, here total is 35 and in question we are talking about 35 students. Okay, no more. We see that 10 occurs in both the classes 0 to 10 and 10 to 20. So if a student scored 10, where he will be counted? To avoid this, we interpret this as class 0 to 10 means all those which are greater than or equal to 0 but less than 10, and so on. Here 0 is called the lower limit and 10 is called the upper limit of the class. The difference between upper limit and lower limit of the class is called class width. Okay, or class of the class. 10 will be counted in interval 10 to 20, as I told you earlier, because it includes the numbers greater or equal to 10 and lesser than 20. Okay. Exercise 5.2. The electricity tax bills of 50 houses in a locality are given here. So you have to construct a grouped frequency distribution with class size of 50. Okay, and this bill is given in rupees. Okay, so students, you will do it by yourself. You have to construct a grouped frequency, and here also class size is given, which is 50. Right. Next, graphical method of representing data. In the previous section, we learned how to draw bar graphs for representing frequency distribution of ungrouped data. Now we shall learn how to represent a grouped frequency distribution graphically. The most common graphic representation is histogram. Okay, what is histogram? A histogram is a graphical representation of a frequency distribution in the form of rectangles with class intervals as bases and heights proportional to corresponding frequencies, such that there is no gap between any two successive rectangles. It is the estimation for probability distribution of continuous variables. Okay, for example, this table shows the marks scored by 200 students in an entrance examination. Okay, so we have to represent this data in the form of a histogram. Okay, see, we represent the class limit along x-axis on a suitable scale and frequencies along y-axis on a suitable scale. Okay, scale is given here. X-axis 1 centimeter is equals to 10 marks and along y-axis 1 centimeter is equals to 4 students. Taking class intervals as base and the corresponding frequencies as heights, we construct rectangles to obtain the histogram on the given frequency distribution as shown in this figure. Okay, example 6. Okay, but first, no more. There are 3 items in statistics: class size, class mark and class interval. Don't mix up these items. These 3 are totally different from each other. Class size, it is use of frequency. Class mark, it is midpoint or the nearest integral value used to represent interval for easy calculations. Class interval, it is the range of variables in which distribution is divided. Okay, and this one, when along x or y axis 0 is taken as origin and next number is not forming equal interval or as other numbers are forming, we use this sign. Okay, or you can use this sign also. These are called zagged lines. Okay, zagged lines, or you can say broken lines. It happens when gap is wide between the 0 and the next number, as you can see in this example also. Okay, so this histogram is depicting the marks obtained by 26 students of a class. Okay, now we have to answer the following question: What is the class size? As you can see, what is the class size? So class size, as you can see, 20, 25, 30, 35, 5, right? Your class size is 5. How many students obtain less than 30 marks? Okay, less than 30 marks means 20 and 25, right? So 2 plus 4 is 6. Third, how many students obtain 50 or more marks? Okay, only 3. The number of students are maximum. Okay, let's check the 240. Four is 3. Exercise 5 histogram of the following data. Okay, students have or pie chart. Pie chart. A pie chart divided into as graph shows the relationship between a subjects. Okay, now the so central angle of 360 degree. Take a table to find the central angle of the to 360. Okay, it's 2. Okay, similarly, we will find out other subjects also. Now we draw radius. Okay, mark its center of the sector, English, that is angle 30 degree using protractor and 120 and 90. Now, okay, with the help of protractor, right? Number 1, on which item the expenditure was minimum? Here, miscellaneous. Okay, as you can see here, number 3, family is 6,000. Okay, rupees 6,000. Income B X. Okay, this 20%. So 20% X is equals to 6,000. T,000. expenditure on clothes is a 3,000. Is what? How much? Is a 20%. That is 30,000. So 25 rupees. Okay. Expenditure of on each. Exercise 5 shows the monthly expenditure. You have a 4,800 and you have 6,000. First, do the total. 6 plus 4, 10 plus. Now the total expenditure. Degree, because we have to find here central angle. Okay, so you will cancel out all the zeros, all the numbers which are getting cancelled out, and after that you will find the central angle and then you will draw pie chart. Okay. Next, chance and probability. There are some situations in which we are sure about the outcome, such as after day there will be night. In desert we are sure to find sand and scorching heat in the daytime, right? On the other hand, there are some questions for which answer can't be simply yes or no, such as we will get enough rains this monsoon. We don't know. Who will be the next president of USA? Nobody knows. Which will be the ruling party in the state of Rajasthan next year? Also, if we toss a coin or throw a dice, we cannot say for certain whether the head or tail will show up or which of the 6 numbers, namely 1, 2, 3, 4, 5 or 6 will turn up. It means outcomes of all such actions depend on chance. Chance plays an important role in life and many important decisions depend on the result of such actions. Gamblers always depend on chance and can make their fortune or ruin it. The probability scale. There are some events for which the answer is simple and sure, such as if we say the sun will set in the east today, it will never happen. Or if we say the sun will rise in the east, it is sure to happen. Okay. In the first case, the probability is 0 and such an event is known as impossible event which can't happen. Okay. However, in the second case, the probability is 1 and the event is known as sure event. This shows that probability has a value greater than or equal to 0 and less than or equal to 1. Okay. Some basic definitions of probability. Random experiment. It is an experiment in which outcome is unpredictable. Number 1, rolling of a unbiased die. Number 2, tossing of a coin. Sample space. The set of all possible outcomes of a random experiment is called sample space connected with the experiment. It is denoted by capital S. Example, next. 1, sample space of tossing of a coin is head or tail, and sample space of rolling of a die is 1, 2, 3, 4, 5, 6. Okay. Event. An event associated with the random experiment is a subset of it. A. Getting a number greater than 4 in rolling of a die is 5 or 6. Okay, and getting an even number in rolling of a die is 2, 4, 6. Next, sample point. All the elements of an event is called sample point. A. 5, 6 are sample points of event E1 and 2, 4, 6 are sample points of event 2. Okay. Next, elementary event or simple event. An event containing only single sample point is called simple or elementary event. Example, getting head in tossing of a coin. Okay. B. Getting a number less than 2 in rolling of a die. Okay. Next, compound event. An event containing more than one sample point is called compound event or composite event. Example, in rolling of a die, getting a prime number. So, we have 3 outcomes, 2, 3 and 5. Sure event. If all sample points of any event are same as the sample points of sample space, then it is called sure event. Example, if a die is rolled, sample space is this. Okay. E1 is an event of getting numbers less than 7 in rolling of a die. So, E1, that is event 1 is 1, 2, 3, 4, 5, 6. E2 is an event of getting either odd or even numbers in rolling of a die, E2. Then 1, 3, 5, 2, 4, 6. So, E1 and E2 are called sure events because sample points of these events, event 1 and event 2 are exactly same as the sample points of sample space. Okay. Impossible event. If no element is favoring the event, then it is impossible event. Example, in rolling of a die, getting a number more than 8. Is it possible more than 8? It is impossible because there are only 6 numbers. Okay. Definition, probability is a way of measuring the chances of occurrence of an event. We calculate the probability, that is PE, of the occurrence of an event by the formula. This is the formula. Number of favorable outcomes upon total number of possible outcomes. Okay. Important note, number 1, probability of all possible outcomes of an event add up to 1. For example, in tossing of a coin, there are only 2 possible outcomes, namely getting head or tail. So, possibility of head is 1 by 2 and possibility of tail is 1 by 2 and possibility of head plus tail is half plus half is equals to 1, right. Number 2, probability of not happening of an event is equals to 1 minus probability of happening of an event. For example, probability of tail is equals to 1 minus probability of head, that is 1 minus half is equals to half. Okay. Where the outcome is a result of an experiment, favorable outcome is an outcome that matches the event. Let us try to understand this from the following example. Okay. Tossing a coin. So, what are the possible outcomes? Either it will come head or either it will come tail. So, possible outcomes are 2, right, events. Getting only head, 1 by 2. Getting only tail is 1 by 2. Next, throw a dice, there are 6 possible outcomes. Getting events, even numbers. So, even numbers are 2, 4, 6 means there are 3 even numbers. So, the probability is 3 by 6 or half. Okay. Probability of odd numbers, getting odd numbers. So, odd numbers are 1, 3, 5. That means 3 by 6 or half. Event 3 is more than 4. More than 4, there are only 2 numbers, 5 and 6. So, the probability is 2 by 6. That is 1 by 3. And event 4, less than 6. Less than 7. Okay, less than 7. 1, 2, 3, 4, 5, 6. 6 numbers are less than 7. So, the probability is 6 by 6, that is 1. And event 5, what does it say? More than 6. More than 6, how is it possible? So, the probability is 0, that is 0 by 6 is equals to 0. And 3, spinning a wheel with numbers 1 to 8. Okay. So, the outcomes, there are total 8 outcomes. So, event 1, only number 8. So, in these numbers, 8 can come only one time. So, the probability is 1 by 8. Okay. Note, form at least 10 more events as done here and find their respective probabilities. Okay. Let's do example 8. What does it say? A bag contains 4 red balls, 4 black balls, 8. A ball is drawn. First, we will do total balls. Total balls 12. Okay. A ball is drawn from the bag. What is the probability of getting a red ball? What is the probability of not a red ball? Okay, so probability of red ball, RB's red ball is what? 4 out of 12, 1 by 3. And second part is what is probability of not red ball? Okay, see, this is the probability of red ball and probability of not red ball. Okay, what will we do? We will subtract this probability from 1. So we will get 3 minus 1 by 3. 2 by 3 is the probability, right? Let's do exercise 5.5. Instead of numbers, the letters in the word chance were stuck on a die. Find the probability of rolling. Okay, so there are 6 letters instead of 6 numbers in a die, chance. So find the probability of rolling letter H. Okay, total outcomes are there 6. So probability of getting H is 1 by 6. Next is vowel. So can you see here how many vowels are there? This is the vowel, this is also vowel. So probability of getting vowel is 2 by 6 or 1 by 3. Number 3, a constant. If 2 are vowels, then remaining letters are constant. That means 4 by 6. That is 2 by 3. And 4 is probability of any letter except A. Means A shouldn't come. That means 5. 5 by 6. Right, students? Now you will do practice of this chapter.